Follow instructions. There are plenty more, but there's 4 of them. Which piece of lab equipment is best for measuring 25 milliliters of water accurately? That's going to be your graduated cylinder. Graduated cylinders are accurate, whereas beakers are not. Okay, so how many significant figures? So these 3 zeros are leading. Leading do not count. So I'm going to put what don't count in red. So leading don't count. Trailing do. So all 4 of these trailing counts. So those 3 numbers count. So that's going to be 3. Here we have our sandwich. I'm going to put that in green. Sandwich, which do count. So all of these count. So we got 5 sig figs. Here we have only the non-zero numbers that count. These all do not count. Leading, no, or sorry, trailing, no decimal. Okay. This one's a leading. Leading do not count. But these other ones are sandwich, so these all count. So we're going to have 1, 2, 3, 4, 5, 6. 6 of those numbers counting, and I keep putting it in green. Here we have a trailing with a decimal. One second.
No, I was just making it. You're good.
Trailing with a decimal. Sorry about that. Trailing with a decimal. So those are going to all count. So that's 4. Here we have a sandwich and trailing with a decimal. So these all count. So we have 1, 2, 3, 4, 5, 6 counting. 6 numbers. Okay, there is the significant figures. So a student measures the length of a pencil 5 times and gets 15.2 centimeters, 15.1 centimeters, 15.3, 15.2, 15.1. The actual length is 13.1. So because the numbers are close to each other, so precision, yes, because the numbers are close to each other. Are they close to the actual number, which is 13? No, so not accurate. So just precise. So a student measures the mass of a calculator 5 times and gets these values. So the questions you ask yourself are they close to each other? Are they close to each other? Well, we have 34 and then 50. They are not close to each other. So they're going to be neither precise nor accurate because they're not close to the actual number or each other. To find precision, you guys look in your notes for this. How close, or I'll just give it to you. How close the values are to each other. Accuracy is how close the numbers are to the true value. So like if you're going to actually hit a bullseye. Or I would say if the numbers are, they're accurate if they're close to the true value. Okay, so to find density. Density, let's calculate density as mass over volume. Remember I said density equals the heart. So our mass is 35.0 grams. And our volume is 5 centimeters cubed. So I'm going to go ahead and plug that into my equation. Both of them have 3 significant figures, so I should end with 3 significant figures. And my units is grams per centimeters cubed, which is also equivalent to 7.00 grams per milliliter. So if you use either of these, you're safe. Okay. Calculate the volume of an object with a mass of 28 grams and a density of 11.4 grams per centimeter cubed. So I'm going to plug that into my equation. 11.4 equals 28 over V. So I need to get V not in the denominator. So because V is being multiplied, I'm going to multiply by V. Or V is being divided, so I'm going to multiply by V on both sides. And I get 11.4 V equals 28. And then I can divide by 11.4. And I get V equals, let me just pull up my calculator real fast. Mm. 11.4, sorry, 28 divided by 11.4. We get 2 point, I want, how many significant figures? Well, this one has 2 and this one has 3. So we want to go with the one that's less because we're dividing. So we're going to go to round to 2 significant figures. So 2.45, 5 tells me I need to round up. So I should get 2.5 milliliters is my final answer with 2 significant figures. Okay, I told you to cross this one off. Let's convert 3.5 weeks to days. So in 1 week, remember we want our units to cross cancel like this. How many days? There is 7 days. So I'm going to do 3.5 times 7. I get 24.5 days. Okay, convert 78.3 km to meters. So my first thing is I want my units to cross cancel. So I put my given on my top left corner, then I put my unit that matches it so my kilometers can cancel, and what I want on the top. And then if I pull up my conversion chart, I'm going from kilometers right here to meters. So I'm going 1, 2, 3, down. Down, if we look down, we're going to be multiplying. The number is going to be on top. Okay. So we're going to multiply by 1 with 3 zeros, and it's going to be on top. 1,000 meters in 1 kilometer. And I'm just going to get rid of that fast. So that I get 78.3 times 1,000. 78,300 meters because I ended in meters. And my kilometers canceled. And I ended with meters. Okay, milliseconds to seconds. So if I go back to my unit conversion, I'm going milli to seconds. So I'm going to go milli to the base. I'm going right here to the base. So I'm going to go up 1, 2, 3. So that means it's going to have 3 zeros, and I'm going up. So if we're going up, so you follow the arrow, we're going up. That means we divide, and the number is on the bottom. So that's going to be 1,000 because there's 3 zeros. So my number is going to be on the bottom. So I have 4,000 milliseconds. In 1,000 milliseconds, there is 1 second. So I get 4 seconds because I'm going to be dividing because it's on the bottom. There you go, 4 seconds. Okay, we have 5,006 days, 2 hours. In one day, we have 24 hours. So which one needs to be on the bottom to cancel? Well, we want our days to be diagonal. So one day needs to go on the bottom and 24 hours on top, which means we multiply. So we get 12,000 hours. Okay, what is the difference between quantitative? Remember, quantitative has the N. Quantitative has to do with numbers. And qualitative is descriptive data. Give an example of each. An example of quantitative is it is 75 degrees Fahrenheit outside. It's not really, today is really cold actually, but that's just an example. And a descriptive measurement would be it is, or observation would be it is hot outside. That's the difference between quantitative and qualitative. Okay, read the following scenario and answer questions 13 through 15. A botanist wants to study the effect of different amount of sunlight on plant growth. She sets up an experiment with 50 identical plants, giving them varying hours of sunlight per day, ranging from 4 to 12 hours. All plants receive the same amount of water and fertilizer. She measures the height of each plant after 30 days. Okay, so let's start with our independent variable. This is what she chooses to manipulate. And then the dependent variable is the measurement. What is she measuring? So actually, I think the dependent is easier. She measures the height of the plant. So the height of the plant is going to be the dependent variable. The effect of different amounts of sunlight. So she's going to give them different varying hours of sunlight per day. So that's going to be our independent variable, our amount of sunlight. Two constants would be the type of plant. Because she says identical plants. And then she also says the water and the fertilizer. So you could have said water and fertilizer. My hypothesis could be if you increase the sunlight, increase your independent variable is the amount of sunlight. Then what do we think? Do we think the plant's going to grow taller or smaller? Probably, maybe I would say taller. So then the plant will grow taller. And if you were in biology class last year, you would probably say because, add the because statement and say that photosynthesis requires sunlight. Okay, so we're going to start with performing the operations, and then we got to round to significant figures. So I'm just going to throw those in my calculator real fast. 45.6 times 3.2. Let me just pull it to the side again. Okay. So we get 145.92, and we're going to round it. So how many significant figures does this one have? It has 3. So when you're multiplying and dividing, you round to the least amount of significant figures. And this one only has 2. So I'm going to round to 2 significant figures. So if I count, here's 1, here's 2. My 5 tells me if I round up or down. So 5 I'm going to round up. So 145 would become 150. So when you're rounding up, you increase the value, and then you just have zeros as placeholders when it's a whole number. 12.35 plus 1.7. Here we're doing our addition. So we're going to go to the least amount of decimal places. So this one has 2 decimal places. This one has 1. So I'm going to round to 1 decimal place. Let me put that. So 1 decimal place 5 tells me to round up, so it would become 14.1. Again, subtraction, least amount of decimal places. So this one has 4, this one has 5, so I need to round to 4 decimal places. 0.0082 minus 0.00073. 0.00747. So that means I'm going to round to this one. My 7 tells me I round up, so we're going to get 0.0075 as my answer. Okay, quickly convert the number to scientific notation. My decimal points here, I'm going to move it over 1, 2, 3, 4, 5. So I get 6.7 times 10 to the 5th. Here I'm going to move over to the right. 1, 2, 3, 4, 5, 6. I want my number in between 1 and 10, my coefficient. But it's a decimal, so it's going to be -6. My decimal place is here because there's a whole number. 1, 2, 3. I get 1.050 times 10 to the 3rd. And then here we're going to do 3.7. I'm going to move it over 1, 2, 3. I'm going to add my, 4, add my 3 zeros. So I get 37,000. 8.21. I'm going to move it to the left because it's a decimal. It's a negative exponent. 1, 2, 3. 0.00821 as my final answer. That should be it for my study guide. Email me if you have any questions.